Let's go ahead for maths. We're doing polynomials and quadratics masterclass for higher maths today. Remember, these examples come from maths.scot, an excellent website, and you can get the cheat sheet and the checklist and the Clelland Maths Pro Vault PDF in the link in the description down below. Remember, if you're doing the Clelland Maths Pro Vault, you've got the answers at the end, and if you need some extra help, you can join the channel to get the full solution, me working through question by question, and access to a last minute live stream the night before the higher maths exam in 2026. Let's go. Okay, example 1. Show that 2x plus 3 is a factor of 2x cubed plus 3x squared minus 2x minus 3, and then factorise it fully. So quite a standard thing. If something is a factor, you can find the root and you can sub it in either directly or using the usual way at higher maths, synthetic division, which we'll probably do here because I think most people in Scotland will be doing that. Okay, so if it's a factor, 2x plus 3 factor, to change that to a root, you imagine it equals 0, or you make it equal to 0. And that means our root, which is what we need to sub in, is x equals minus 3 over 2. Change the sign on the 3 and divide by 2. Quite a hard one, this, but, you know, hey ho. Let's jump in. 2x cubed, 3x squared, minus 2x, minus 3, and we're subbing in minus 3 over 2 as our root. So we're never subbing the factor. So if you know the factor was x plus 2, you're subbing in minus 2. Okay? So what we got here, we take 2 down, we then times by minus 3 over 2. Well, that's fine, because 2 3s is 6. 6 divided by 2 is 3 again, so we get minus 3. 3 add minus 3 is 0, so it's not as hard as it looks, because 0 times something is 0. 0 minus 2 is minus 2 again. Minus 2 times minus 3 is 6. 6 divided by 2 is 3. And 3 minus 3 is 0. If you don't get 0 here, you've done something wrong. You now need a statement. A simple statement would be the remainder equals 0. So, what was it? 2x plus 3 is a factor. The other way to do your statement, for the sake of completeness, is just to say f of minus 3 over 2 equals 0, and therefore 2x plus 3 is a factor. But this is the most common one. Part B, factorise it fully. So let's jump into factorising. Well, we already know that 2x plus 3 is a factor, so I can just write that again. Make sure you don't forget that one. And to get your other one, it's underneath here. That goes down by 1 power, so it's 2x squared, 0x minus 2. 2x squared minus 2. Now, in this case, you need to check for common factors and you need to check if it's factorisable. So 2 is a common factor of that bracket, so that can go in front. And you get x squared minus 1, but that's a difference of 2 squares. X plus 1, x minus 1, and it only asks us to factorise it, not solve it equal to 0, so we're done there. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code Clelland Maths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Clelland Maths. Click the link to order now. Example 2. It just jumps in. Factorise fully. Don't know a factor. There is ways to get a factor, but the easiest way is to times them together. So minus 10. I'm looking for numbers that go into minus 10, not anymore. So 3 is never going to work. Chances are it's going to be a small number like 1 or 2. So you just check them. Now, some people do this by synthetic division straight away, but I think it's easier just to sub in directly. So if I try like x equals 1, I can just do 2 times 1 cubed plus 9 times 1 squared minus 6 times 1 minus 5. And if I get 0, it is a root, so x minus 1 is a factor. So 2 times 1 cubed is 2, 9 times 1 squared is 9, minus 6 minus 5. I think I've been very lucky here. 2 plus 9 is 11, minus 6 minus 5 is 0. If I hadn't got 0, I would try minus 1. And if that didn't work, I'd try 2, then minus 2. Hopefully you won't have to do it for too long. But just checking our numbers, that looks good. Therefore, x minus 1 is a factor because the remainder equals 0. I can say that there, or I can say it after I do my synthetic division. But now I need to actually do my synthetic division. So x minus 1 is a factor. We always sub in the root. So it's 1 we're subbing in. Get that one right and you'll be fine. 2x cubed, 9x squared, minus 6x, minus 5. The 2 comes down. 2 times 1 is 2. 2 add 9 is 11. 1 times 11 is 11. 11 minus 6 is 5. 5 ones is 5. 5 minus 5 is 0. I don't need to say the remainder equals 0 again, but if you've not done it yet, you say it now. And that means that x minus 1 is a factor. So we knew it was x minus 1, but we've now got 2x squared plus 11x plus 5. And we need to check, is that factorisable? Now, you might be able to see it's factorisable. If you're not sure, do b squared minus 4ac. I'll write that at the side. And if that's a square, then you need to go back and factorise. If it's not a square, you then just say that's your answer because it doesn't factorise further. So x minus 1, most of the time it will factorise further though. 2x and x, 2 5s is 10 plus 1 is 11. Outside, inside. So that is that and that, and we're done there. If you need help with factorising, check with National 5 Maths. Example 3 on Quadratics and Polynomials Masterclass. Show that x plus 2 is a factor and then factorise it. So it's a fourth power 1, so it's going to go down to a cube, which means we're going to have to guess one from the cube, which is unfortunate, but that's how it goes. So part A, I can sub in minus 2. I might as well do it in synthetic division. So that gives me 2x4, 9x cubed, minus 1x squared, minus 18x, plus 8. 2 comes down, 2 2s is 4, so that's minus 4. 9 minus 4 is 5. 2 5s is 10, so that's minus 10, so minus 11. 2 11s is 22. 22 minus 18 is 4, and 4 times 2 is minus 8 again to get 0. Little statement, don't forget your statement. Remainder equals 0, therefore x plus 2 is a factor. Part B, let's go and factorise. So we've got x plus 2, keeping that here, and then we've got 2x squared, and that's a mistake, it's cubed because I started with a 4, so watch out for that. It goes down by 1 power. Don't think it just always goes to a square. Plus 5x squared minus 11x plus 4. So we need to know numbers, things that go into this second bit. So we can just try our numbers again. 2 times 4 is 8, so I'm looking for factors of 8. Where did I get that? 2 times 4. I'll try 1. X equals 1, and you just need to sub it into the 2x cubed part. So 2 times 1 cubed plus 5 times 1 squared minus 11 times 1 plus 4 equals 2 plus 5 minus 11 plus 4. 5, 6, 7, 8, 9, 10, 11. 11 minus 11 is 0. So again, I've been lucky that it's 1. And quite often that will happen, to be honest, or minus 1. Since I've got a remainder of 0, I write that. Remainder equals 0. Therefore, x minus 1 is a factor because I subbed in 1. Now I need to sub it in again, but using synthetic division to get my other roots. So I draw my synthetic division thing, but just for the 2x cubed part. So 2, 5, minus 11, 4, subbing in my 1. 2, 2 ones is 2, 2 and 5 is 7. 7 minus 11 is minus 4. We should get 0 at the end, which we do, so we can continue. Now we've got x plus 2, don't forget that. X minus 1 we just worked out, and 2x squared plus 7x minus 4. Now, does that factorise? If not, you're done. How do we know? Either you just do it, or b squared minus 4ac. If that is not a square number, it's not factorisable. So if you're not sure, check that first. I know that 2 4s is 8 and 1 is 7, so I know that it will factorise. So I get x plus 2 and x minus 1. 2x, x. Outside would be 8, 2 fours is 8, and middle is 1 to make the 7. I want to make plus 7, so plus 8 minus 1. Just double check by expanding it. 2 8s, 2 4s. See, I've written 8 even though I said 4. 2 4s is 8, minus 1 is 7, and we're done. We've completely factorised it. 4. Show that x minus 3 is a factor and factorise fully. Part A, we're doing the normal thing then. 3 goes in. 2x4 minus 3x cubed. And then you might want to like minus 19. I almost did, but there's no x squared. Watch out for that. You write 0. No x squared. Minus 19. Minus 24. And you'll see if you do it without that, you'll get not 0 in the end. You'll think, what's going on? Something's wrong. You need to think. 2. 2 threes is 6. 6 minus 3 is 3. 3 threes is 9. 9 plus 0 is still 9. 3 nines is 27. 27 minus 19 is 8. 8 threes is 24. And that gives me 0. Therefore, we say that remainder equals 0. So x minus 3 is a factor. And then we can move on to part B. Hence factorise fully. So part B, we've already done some of the work. X minus 3 is a factor. And then we've got 2x, that's cubed, 3x squared, 9x, and 8. So we need factors of 2 and 8, which is 16, for that bit. We already know 3 is 1. So let's just try 1. We'll just go in order. There's no point doing anything else. 2, 1. Putting 1 in, we get 2 times 1 cubed. 3 times 1 squared, 9 times 1 plus 8. That's 2 plus 3 plus 9 plus 8, which does not equal 0 because it equals 1722. So 1's not a factor. Try 2 minus 1. Minus 1 cubed, minus 1 squared, minus 1, 8. Minus 1 cubed is minus 1, so that's minus 2. Minus 1 squared is 1, so that's 3. Minus 9 plus 8. 3 minus 2 is 1. 1 plus 8 is 9 minus 9. That gives me 0, so I've got it. Excellent. Remainder equals 0. Therefore, x equals minus 1. X plus 1 is a factor. And now we can try and factorise it by doing synthetic division again. Notice I always sub in first because I think it's easier to do that than synthetic division over and over again. It's just quicker. But if you find synthetic division over and over again until you get the right answer, that's fine. So we do my synthetic division. So let's just check what we've got. We're subbing in minus 1 and we started off with 2x cubed, 3x squared, 9x and 8. So that's 2 minus 2, 3 minus 2 is 1, minus 1, 9 minus 1 is 8, minus 8 and 0. So now we can keep going. We had x minus 3 is a factor, x plus 1 is a factor, 2x squared plus x plus 8. Now, is that factorisable? Well, if you do b squared minus 4ac, if you don't get a square number, it's not factorisable. But even better, if you get a negative, it means there's no more roots, no real roots anyway. So I would do a quick check. 2 8s is 16. That doesn't work. 2 4s is 8. 8 and 2. I'm getting a feeling it's not going to work. So let's just check b squared minus 4ac. And this is always a handy tip to do, even if it is working. It means you can go back and do it anyway. So that's 1 squared minus 4 times 2 times 8. That's 1. 4 2s is 8. 8 8s is 64, which is minus 63. b squared minus 4ac is less than 0, so no real roots, and therefore that's our answer. And we're done there. Okay, example 5. For the polynomial x cubed minus x squared plus mx plus n, some unknowns, we know that x minus 3 is a factor, and we know that 54 is a remainder when we divide by x minus 5. Find the values of m and n. So this is really testing, do you understand this thing that we're doing, this synthetic division? Remember, the last number you get is the remainder, and if it's 0, it's a factor. If it's not 0, it's not, but it still tells you something, okay? So let's see what it tells us. Let's put in 3 first, because it's x minus 3 is a factor, so 3 is our root. 1 minus 1, m and n. You can do it with synthetic division, or you can just sub in directly. 1 times 3 is 3, 3 minus 1 is 2, 2 3s is 6, 6 plus m, and then it times by 3, 18 plus 3m, 18 plus 3m plus n. But we know that bit's 0, because since x minus 3 is a factor, remainder equals 0. So we can straight away say that 18 plus 3m plus n equals 0. We've got an equation. Can we get another one? Well, let's check the other statement. X minus 5 gives 54. So if I sub in 5 instead of minus 5, 1 minus 1m and n, you get 1. 1 5s is 5. 5 minus 1 is 4. 4 5s is 20. 20 plus m. 5 times 20 is 100. 5 times m is 5m. 100 plus 5m plus n. But we say that remainder, remember, which is that last position, was equal to 54, I think. So now all we need to do is say 100n plus 5m plus n equals 54. We've got simultaneous equations, so we can solve them. Let's tidy up our simultaneous equations. So our first one is 18 plus 3m plus n, so I might as well say 3m plus n is minus 18. And the second one, we've got 5m plus n. I'll just leave that on the left. 54 take away 100. Well, that's 64, 74, 84, 94, which makes 46. So it's minus 46. I can take away, well, I'll call that 1 and 2. 2 take away 1. Gets rid of it ends. So that gives me 2m. Minus 46 minus minus 18. Watch out. So it's add 18. So minus 46, add 18 is minus 36 minus 28, I think. Just double check that. 28 becomes 38 becomes 46. So m is minus 14. Sub into whatever one you want. Let's take the first one. 3m plus n minus 18. 3 14s then. 3 4s is 12. 3 10s is 30. So that's 30, 42. Moving the 42 over becomes positive. 42 take away 18 is 32, 24. And assuming that was the whole question, no, just find m and n. We've got a part B as well. But we've found m and n, so we'll go into part B in a minute. Part B says, hence solve x cubed minus x squared plus mx plus n equals 0. Well, we've already got everything we need to know. It's x cubed minus x squared plus mx plus n. But we already know, since that's the same as we started with, that x minus 3 is a factor. So we could actually just swap out our m's and n's in here, or just do it again. It's probably easier just to do it again, to be honest with you. So you get 1 minus 14, 24. And it was x minus 3, so we're subbing in 3 to get 1, 3, 2, 6. 6 minus 14 is minus 8. 3/8 is 24, but a minus, so we get 0. Remainder 0. You don't need to actually write it because you were told, but we'll just do it anyway. So x minus 3 is a factor. So we've got x minus 3, x squared plus 2x minus 8. And it says, did it say solve it or factorize it? Solve it equal to 0. So that means that we actually have to factorize and solve 4 and 2 plus 4 minus 2. So each bracket equals 0. So x is 3, x is 2, x is minus 4. And we're done there. Example 6. The same remainder is found when x cubed minus 6x squared plus 2x minus p and x cubed plus 5x squared plus 2p plus 1x minus 37 is divided by x plus 2. Find the value of p. So in other words, we need to sub in minus 2 synthetic division or standard and make them equal to each other. So let's just do it with synthetic division, but you can just sub in directly if you prefer. That is not a lot of people will. 1 minus 6, 2 minus p, and we're subbing in minus 2. 1 minus 2, minus 2 take away 6. Minus 2 take away 6, minus 8, 16, 18, minus 36, minus 36, minus p. So there's our first one. And then the next one, 1, 5, 2p plus 1, and minus 37. And we're subbing in minus 2 again. 1 minus 2 plus 5 is 3. 3 times minus 2 is minus 6. 2p, 1 minus 6 is minus 5. And then 2 2s is 4. 2 5s is 10, but it's a plus. So minus 4p. 10 minus 37 is minus 27. Remainder same. So they equal each other. Minus 36 minus p is minus 4p minus 27. I'll move the 4p to the left to get 3p. And I'll move the 36 to the right. So that's 36 minus 27. 27 is 9. And then we get p is 3. So we're done there. Okay, example 7. X cubed plus 3x squared minus 4x minus 12 equals 0. Just to solve it. So we need to find factors that go in. So minus 12 is the number because it's 1x cubed. So we can try 1. 1 cubed plus 3 1s squared minus 4 1s minus 12. That's 1 plus 3 minus 4 minus 12. So that's 1 plus 3 is 4 minus 4. That's minus 12. So that's not a factor. So we try minus 1. So that's minus 1 plus 3 plus 4 minus 12. 3 minus 1 is 2. 2 plus 4 is 6. 6 minus 12 is minus 6. So we need to keep going. Factors of 12. 2. 2 cubed plus 3 2 squareds minus 4 2s minus 12. 8. 2 2s is 4. 4 3s is 12. 4 2s is 8. And then minus 12. 8 minus 8 is nothing. 12 minus 12 is nothing. So we've got it finally. The remainder equals 0. Therefore, 2 is subbed in. X minus 2 is a factor. So we can continue with our synthetic division. So it was 1, 3 minus 4 minus 12. Subbing in 2 to get 1. 2. 2 plus 3 is 5. 5 twos is 10. 10 minus 4 is 6. 6 twos is 12 and 0. So we've got x minus 2, x squared plus 5x plus 6. And we have to solve it equal to 0. X minus 2, x plus 3, x plus 2. 3 twos is 6. 3 plus 2 is 5. So x is 2. X is minus 3. X is minus 2. And we're done there. Example 8, we have to solve this one equal to 0, so we need to find numbers that go in. So let's try x equal 1. 1, 4 minus 1 cubed minus 10 times 1 squared plus 4 ones plus 24. 1 minus 1 minus 10 plus 4 plus 24. Well, that's not going to be 0 because that's 24 minus 10 is 14 plus 4 is 18. So we try 2. Or minus 1 actually. And we just keep going until we find 1. And hopefully it doesn't take too long. But factor to 24, it could be quite a few. Minus 1 to the power of 4 is 1. Minus 1 cubed is minus 1. Times minus is a plus. Minus 1 squared is 1. So that's minus 10. Minus 4 plus 24. 1 plus 1 is 2. 26. Minus 14 is 12. So it's not that or that. Try 2. 2 to the 4 minus 2 cubed minus 10 2 squared plus 4 2s plus 24. 2 to the 4, 2 2s is 4 to 2 is 8 times 2 is 16 minus 8. 2 2s is 4 minus 40 plus 8 plus 24. So we've got 16 minus 8 is 8 plus 8 is another 16 plus 24 is 40 minus 40 is 0. We've finally found a factor. It's 2. So we can sub in the 2 and we can get a cubic. Remainder equals 0. So x minus 2 is a factor. 1 minus 1 minus 10. 4 and 24. 1 comes down. 2 ones is 2, minus 1 is 1. 2 ones is 2, minus 10 is minus 8, minus 16, minus 12, minus 24 and 0. So we've got x minus 2, x cubed plus x squared minus 8x minus 12 equals 0. Now, there's no point trying 1 minus 1 and 2 again because we already know that 1 minus 1 doesn't work and 2's already got 1. So we next try x equals minus 2. Quick check, minus 2 cubed, minus 2 squared, minus 8 minus 2 is minus 12 is minus 8 plus 4 plus 16 minus 12. Minus 16 plus 4 is 20. Minus 8 minus 12 is 0. So we've got minus 2. You could have just subbed it straight in, but if minus 2 didn't work, you would have to try another one. So you might as well just go for there. Remainder equals 0. So x plus 2 is a factor. So we've now got to put in our minus 2 into the cubic. 1, 1, minus 8 minus 12. To reduce it down to 1, minus 2 add 1 is minus 1, that's 2, 2 minus 8 is minus 6, 6 times minus 2, well minus times a minus is a plus, so that's 0. We've already made our statement, so I don't need to make it again. We now know our factors, keeping track, x minus 2, x plus 2, x squared minus x minus 6. So we're looking to see is x squared minus x minus 6 factorisable. So then we can just continue factorising. X minus 2, x plus 2, x and x. 3 and 2 make 6. So we've got minus 6 minus 1, so minus 3 add 2 equals 0. So x equals 2 from that one, x equals minus 2 from that one. It's a repeated root, x equals 3. So our answers are, since we've got a repeated root, x equals 2, x equals minus 2, and x equals 3. And we're done there. Example 9. The graph of y equals f of x, where f of x equals kx minus a x minus b squared, has a minimum turning point at 3, 0, a root at minus 2, and passes through the point 148. Find the values of a, b, and k. So, lots of information here. We've got a root at minus 2. Remember, roots become factors. So we know a factor is x plus 2 straight away. We've got a turning point, TP I'll call it, at 3, 0. In other words, when x equals 3 is a turning point, but we've got a repeated root, which means that that is a turning point. Because it's 3, 0, so it's on the axis. The turning point on the axis means a repeated root. So that means that our a straight away, x minus a, it's x plus 2 is minus 2. And our b, x equals 3, so it's x minus 3. B is just 3. Now to get our k, we just sub in our point, x and y. So for a equals k, x plus 2, because a is minus 2, x minus 3 squared, but we're replacing that x with 1. So 48 equals k times 3 times minus 2 squared. So 48 equals 4 3s is 12, k, and therefore k is 12, 24, 46, 48. It's 4, and we're done there. Okay, example 10. Find the values of k so that this has equal roots. So we're now onto the quadratic section massively here. If it's mentioning equal roots, we're looking at the discriminant. So b squared minus 4ac, if it's equal roots, is equal to 0. Our b is k plus 3. Minus 4 times 1 times 4 equals 0. K squared. 3k becomes 6k because it's k plus 3 plus 9. And then 4 4s is 16. K plus 6k. 9 minus 16 is minus 7. Factorise it out. K and k. 7 and 1. Minus 7 plus 7 minus 1. So k equals 1 and k equals minus 7. And we're done there. Okay, question 11 on quadratics. Find the range of values of p so it has no real roots. B squared minus 4ac then is less than 0 for no real roots. So our b is 5 minus 4 times 2 times p plus 1. 25. 4 2s is 8. So minus 8p. 8 times 1 is 8 minus 8. So 25 minus 8 is 17. So minus 8p is less than minus 17. So p is greater than 17 over 8 because it's a flipper because we're dividing by a minus. And we're done there. Example 12. Find the range of values of a so that it has two distinct real roots. If it's got two distinct real roots, the discriminant is greater than 0. So minus 6 squared minus 4 times 1, and a is hanging on the end, so that's our c. 36 minus 4a. So minus 4a is greater than minus 36. A is less than 9 because it's a flipper because it's divided by a minus, and I'm done there. Example 13. Find the range of values of n so that this has two distinct real roots. B squared minus 4ac then is greater than 0. B is minus n, minus 4 times 1, and then we've got on the end 3 minus n. Now this is going to give a quadratic, n squared, 4 3s is 12, and 4 times n is plus 4n, because a minus times a minus. Let's get that in the correct order. Now to solve a quadratic inequality, you need to check the roots. So looking at our roots, n squared plus 4n minus 12 equals 0. 6 and 2 I think is going to work. Plus 6 minus 2, so I've got a root at 2 and a root at minus 6, and then you just draw a graph. So this is how you always solve quadratic inequalities. 2 and minus 6, n was positive. Doesn't really matter if that's particularly accurate. The main thing is we want it to be greater than 0, so we're above the x-axis, so that keeps going to the right and it keeps going to the left. We're stuck in between. If we get stuck here and here, that would be below. So that means that x, or n in this case, is less than minus 6, or n is bigger than 2 is our answers, and we're done there. Example 14. A rectangle has length x, breadth 1 centimetre shorter than length. Area is less than 30. Calculate the range of possible values of x. So I'm going to have to create some sort of equation or inequality here. Let me just draw a rectangle so I can visualize this. Its length is x. Its breadth is 1 centimetre shorter than length. 1 less x minus 1 then. And the area is less than 30. Well, how do you do the area? Length times breadth. So it's just x minus 1 is less than 30. X squared minus x is less than 30. It's got an x squared in it, so I need to take it to 0. And it's a quadratic inequality, so I need to show how I know which is which. So I always do it by the root method and drawing a graph. So looking at our roots, x and x, 5 sixes is 30. Minus 6 plus 5 is minus 1. So x is minus 5 is a root and x is 6. Quick sketch, minus 5 and 6. It is a positive x squared. So we're going down and up. Wee quick sketch, and it's less than 0 this time. So we're stuck under the x-axis in between. So we can just say that minus 5 is less than x is less than 6. And we're done there. However, this is an actual rectangle. Whenever you're doing a geometric problem, you need to think, does the answer make sense? Well, since it's a rectangle, you can't have a negative length. So in actual fact, since that is our actual solution for the quadratic inequality, but for our rectangle, we would have to say that x can never be negative. So you can't have anything that creates that to be negative. So x has to be at least 1, or in other words, 0 is less than x is less than 6, because x is bigger than 0. In fact, that's not even true as well, though, because that just takes into account the length, but the breadth is 1 less than the length, so the breadth can never be 0. So really, it actually goes between 1 and x and 6, because if you look at that, if x was less than 1, you would get like 0.5. 0.5 minus 1 will give you a negative breadth as well. So it has to be at least 1. So there we are. Our answer is 1 is less than x less than 6. Quite tricky, that one. Example 15. Express minus 2x squared plus 12x plus 5 in the form ax plus b squared plus c. Completing the square. Here's my method for this. I factorise here and leave the 5 at the end. So I just say, look, I've got minus 2 as a common factor, or 2 if you prefer, of x squared. I don't need that extra bracket, that's confusing. X squared plus well, that's going to be a minus actually, 6x, and then plus 5 hanging on the end. And now I just completely square on this bit like normal. So that's minus 2, half the middle term, and then immediately take away 3 squared. But that's stuck inside the bracket to go over 2, and the 5 is hanging on the end. So that's minus 2, x minus 3 squared. Minus times a minus is a plus 18 and a plus 5. So finally, x minus 3 squared, 18 plus 5 is 23. And we're done there. And the reason you do that, of course, is it tells you the turning point. It's still 3 and 23. The minus 2 makes no difference to that turning point. Example 16, on completing the square, express that in the form px plus q squared plus r. So 4 is a common factor of the first two things. So 4x squared, 4 sevens is 28, 7x. And I've still got minus 1. So 4x minus, we're in higher maths now, so fractions, 7 over 2 all squared. And then I immediately take away 7 over 2 all squared. Well, 7 sevens is 49. 2 2s is 4. And I've still got minus 1 on the end. So being very careful, x minus 7 over 2 all squared. 4 divided by 4 is 1, so that's just minus 49 and minus 1 on the end to finally give me 4x minus 7 over 2 all squared minus 50. And we're done there. Example 17. Determine the points of intersection of a parabola y equals x squared plus 3x minus 7 and the line y equals 4x minus 1. Point of intersection means simultaneous equations. So that's x squared plus 3x minus 7 equals 4x minus 1. X squared we can stay here. 4x comes over, so that's minus x. Minus 1 becomes plus 1, so that's minus 6. Equals 0. So now we need to check if it's factorizable. So we've got x and x, 3 and 2, minus 3, plus 2 is minus 1, minus 3 times 2 is minus 6. So x is minus 2 from the first one and x is 3. But we're not done there because we want the whole point of intersection, so we need to sub that into y. Y is 4x minus 1. So when x is minus 2, y is 4 times minus 2 is minus 8, minus 1, minus 9. So we've got minus 2, minus 9. And for the other one, when x is 3, y equals 4 3s is 12, minus a 1 is 11. So that gives me 3, 11. And we're done there. Example 18. The line y equals 5x minus 3 and the curve x cubed minus 8x plus 9 intersect at 3 points. One of these points is 3, 12. Find the coordinates of the other 2 points. Well, point of intersection means simultaneous equations. X cubed minus 8x plus 9 equals 5x minus 3. So we can take it across. X cubed minus 5 minus 8 is minus 13. 9 plus 3 is 12. So we're solving a cubic here, which is a polynomial. But good thing is, it told us that one of the points is 3. So x equals 3 is a root. In other words, x minus 3 is a factor for this. So we can now just go into synthetic division to find the rest. 3, 1x cubed, 0x squared, minus 13x, plus 12. And that'll confirm that you're getting 3 out. 1 times 3 is 3. 3 plus nothing is 3. 3 3s are 9. 9 minus 13 is minus 4. 3 minus 4 is minus 12. 0. So it gave us one of the roots, which is nice. We'll still write this statement because we're just a bit used to writing it after the synthetic division. But you don't really need it, since we've already said it up there. So now we've got x minus 3 x squared plus 3x minus 4, x minus 3, x and x, and 4 and 1 make 3 when you take away, so plus 4 minus 1, so x equals 3, which we've already got, x is 1 and x is minus 4. We want a full point, but y was equal to 5x minus 3, so when y equals 5x minus 3, when x is 1, y is 5 minus 3 is 2, so the other point is 1, 2, and when x is minus 4, y equals minus 23, because that's 5 times minus 4 is minus 20, take away 3, so the point is minus 4 minus 23. There's our other points of intersection, so we're done there. Example 19, SQA Higher Maths 2023, Paper 1, Question 5. Let's take a look at the solution. SQA Higher Maths 2023, Paper 1, Question 5. The equation 2x squared plus 3p minus 2x plus p has equal roots. So if it's got equal roots, b squared minus 4ac equals 0. So our a is just the number in front of x squared, which is 2x. Our b is 3p minus 2, the number in front of x. And our c is whatever's left on the end, which is p. So we can do b squared minus 4ac, 3p minus 2 squared minus 4 times 2 times p equals 0. So we need to expand the double bracket. The quick way with a squared bracket is square the first. 3p is 9p squared. Twice them times together, so 2 3s are 6, times 2 is 12, so you get minus 12p. And then square the last, 2 2s are 4. So that's our first bracket. Then minus 4 times 2 is 8, times p is minus 8p equals 0. So we get 9p squared minus 20p plus 4 equals 0. Now we need to see if that can factorise. That's a bit of a nasty one. So I'll briefly go over factorising. We do 9 times 4 is 36. I'm looking for factors of 36 that add together to make minus 20, or 20 I suppose. So 1 and 36 is not going to work. 2 and 18 will work because I can now do minus 2 minus 18 equals minus 20, and minus 2 times minus 18 is 36. So I can split this middle term up into 9p squared minus 18p minus 2p plus 4 equals 0. So then to factorise it, I'll just factorise like this dotted line. So taking 9p out as a common factor, I'll get p minus 2. And on the other side, I'm still needing p minus 2 because I want the same factor. So times by minus 2 to get minus 2p, and just check minus 2 times minus 2 is plus 4. So then my factorisation is complete. It's what's outside the brackets, 9p minus 2, and the inside p minus 2 equals 0. So 9p minus 2 equals 0, or p minus 2 equals 0. Solving the left-hand side one, 9p equals 2, so p is 2/9. That's our first solution, or p equals 2. And that's our second solution, and we're done there. Example 20, SQA Higher Maths 2023, Paper 1, Question 10. Let's look at the solution to that. SQA Higher Maths 2023, Paper 1, Question 10. Show that x plus 5 is a factor of this, and it's a 4th power one. And then hence or otherwise solve it equal to 0. So usually we do cubics, but 4th powers can come up. So you're going to show it's a factor, you're going to end up with a cubic, and you're going to have to then start with a cubic by just guess and check to find another factor. So let's start off showing it's a factor. Easiest way is using synthetic division. So x plus 5 is a factor, so I'm subbing in minus 5. So it's 1x to the 4 plus 3x to the cubed minus 7x squared plus 9x minus 30. So we drop the 1 down, times them together to get minus 5. Minus 5 plus 3 is minus 2. Times it by minus 5 again, you get 10. 10 minus 7 is 3. Times by minus 5 again to get minus 15. Minus 15 plus 9 is minus 6. Times it by minus 5 again to get 30. 30 minus 30 is 0. Two options for your statement. You could write f of minus 5 equals 0, and therefore x plus 5 is a factor. Or the alternative is just writing since the remainder is 0, x plus 5 is a factor. Either of the options are fine, but you need to write a statement. Hence, otherwise solve the equation. So part B, we now know that it becomes x plus 5. Then you've got x cubed minus 2x squared plus 3x minus 6 equals 0. We're going to have to check numbers here to find another factor. So the easiest way is direct substitution. So if I try 1, we're going to get 1 cubed minus 2 times 1 squared plus 3 times 1 minus 6. 1 cubed is 1. Minus 2 is minus 1. Minus 1 plus 3 is 2 minus 6 is minus 4. So it's not that one. Try minus 1. You get minus 1 cubed minus 2 times minus 1 squared plus 3 times minus 1 minus 6. Minus 1 cubed is minus 1. Minus 2 is minus 3. Minus 3 is minus 6. Minus 6 is minus 12. So it's not that one. So then you would try 2, and you're just doing it systematically. Once you get bigger, you can go back to synthetic division. I'll stick with this for 2, because it's quite simple. 2 cubed minus 2 times 2 squared plus 3 times 2 minus 6. That's 8. 2 2s are 4 times 2 is 8. Plus 6 minus 6, that's 0. Therefore, we've got another factor of x minus 2. So we're going to have to synthetic division it anyway, but we now know 2 goes in. So synthetic division just on the x cubed minus 3x squared plus 3x minus 6. 1x cubed minus 2x squared plus 3x minus 6. And we're subbing it in 2. Now you could have just done that to the start and done it for 1, minus 1, 2, and so on. We've got 1, 2 1s are 2, minus 2 is 0, 0 again, plus 3, 3 2s are 6, get 0. So because since f of 2 equals 0, x minus 2 is a factor. Or since the remainder is 0. At this stage, you don't have to show that it's a factor, so you don't really have to need the statement, but just to be on the safe side. So we've got x plus 3 still, x plus 5 still, sorry, and then x minus 2. So that implies our original function, which is x4 plus 3x cubed minus 7x squared plus 9x minus 30 equals 0 becomes x plus 5, x minus 2, and then we've got, this has become a quadratic, x squared plus 0x plus 3, and that equals 0. Now we need to solve it, so each factor becomes equal to 0, so that implies that x plus 5 equals 0, or x minus 2 equals 0, or we could say x plus 3 equals 0. The first one gives us x equals minus 5, second x equals 2, and this one, no solutions, because if you take it over to the other side, you get x squared equals minus 3, and you can't square a negative number. Example 21, SQA Higher Maths 2024, Paper 1, Question 8. Let's have a look at the solution to that one. SQA Higher Maths 2024, Paper 1, Question 8. The equation x squared plus m minus 4x plus 2m minus 3 has no real roots. Determine the range of values for m. So if it's got no real roots, that means that b squared minus 4ac must be less than 0. So a is equal to 1. B is m minus 4, and C is 2m minus 3. So we're just going to sub that in. So we've got m minus 4 squared minus 4 times 1 times 2m minus 3, and that's less than 0. So that's m squared minus 8m plus 16, take your time expanding. 4 times 1 is 4, times 2 is 8, so minus 8m. And then minus times a minus is a plus, so plus 12, less than 0. So that gives me m squared minus 16m, and then plus 28 is less than 0. So this is a quadratic inequality. So what we do with these is we look at the roots and draw a little graph. So the roots, we've got double brackets, m and m. And for the roots, we've got 14 and 2. Minus 14 minus 2 is minus 16. 14 2s is 28. So we get m equal 2 and m equal 14 as our roots. So we now draw a graph. Just a rough one. There's 14. There's 2. There's your quadratic. It was positive, yep. And we want it less than 0. So underneath here, that's between these two numbers. So our final answer is 2 is less than m is less than 14. And we're done there. Example 22. SQA Higher Maths 2024 Paper 1 Question 10. Let's look at that one. SQA Higher Maths 2024 Paper 1 Question 10. Show that x minus 1 is a factor of that and then factorise it fully. We're just going to use synthetic division. 2, 3, minus 4, minus 3, 2. Put in 1 in. We get 2. 2 ones is 2. Plus is 5. That's 5. 5 minus 4 is 1. That's 1. 1 minus 3 is minus 2. That's minus 2. And we get 0. We just say remainder 0. So x minus 1 is a factor. So now we have to factorise it fully. So for part B, we've now got x minus 1 times 2x cubed plus 5x squared plus x minus 2. So I need to find another factor. Now I've already got minus 1, so I could try 1, I could try 2 or minus 2. Or I could try any multiple of 2 times 2 is 4, any factor. Now I'm going to try, I've already done this to be fair with you, and I got it on 1. But you just keep trying numbers till it works. If you can't do it, I've got 2, 5, 1 and minus 2. And I know that minus 2 is going to, does work. So I get 2, 2 2s is 4, 5 minus 4 is 1, that's minus 2, plus 1 is minus 1, that's 2, that's 0. So again, remainder 0. That means that x minus plus 2 is a factor, because I put in minus 2. So then we can continue to factorise. X minus 1, x plus 2, and 2x squared plus x minus 1. So just check if that's factorisable. You can either see it or you can just check in some other way. But I can see it as factorisable. 2x and x. 2 1s is 2, and then 1. So I want plus 2 minus 1. 2x squared plus 2x minus 1x is x. Minus 1 times 1 is 1 minus 1, so we're done there. SQA Higher Maths 2025 Paper 1 Question 7. Show that x plus 3 is a factor of this, and then hence otherwise solve. So you can sub in directly, or as most of you will do, you'll use this synthetic division. So you've got 5, 16, minus 1, minus 12, x plus 3, so I sub in minus 3. 5 minus 15. 16 minus 15 is 1. 1 times minus 3 is minus 3. Minus 3 minus 1 is minus 4. Minus 3 times minus 4 is 12. And we will get 0. So since the remainder equals 0, that implies that x plus 3 is a factor. Well, the way you could say that is f of minus 3 is 0, so x plus 3 is a factor. Now we have to solve it, and it's the same equation. So for part B, we've already got x plus 3 as a factor, so I'll just write that again. And then we've got 5, 1 minus 4, 5x squared plus x minus 4 equals 0. So a little bit of hard factorising if it does factorise. Now if you're not sure if it factorises, check the discriminant. 1 squared is 1, 4 5s is 20, 20 times 4 is 60, and that's positive, isn't it? 4 5s is 20. If you're not sure it factorises, check the discriminant. If the discriminant is a square number, it's factorisable. So 1 squared is 1, 4 5s is 20. 20 times 4 is 80. That's a minus minus. That gives you 81 for the discriminant. So that means it's definitely factorizable because 9 nines is 81. So a little quick check there. And if you've got a negative number for your discriminant, you know you've got all the solutions. So it must be 5x and x. I was going to write 5x twice there. And it can't be 5 times 4 is 20. That makes no sense because I'll never get back down to 1. So it must be 5 times 1, which is 5. The outside is 5. And then the inside must be 4, taking away 4. Take away 4 plus 1. So that means that x is equal to minus 3. 5x minus 4 is 0. 5x is 4. So x is 4/5. And finally, the other one, x equals minus 1. And we're done there. Next we have maths 2025, paper 1, question 11. The equation 9x squared plus 3kx plus k is 0 has two real and distinct roots. Find the values or range of values for k. So if we've got two real and distinct roots, the discriminant must be strictly greater than 0. Not even greater than or equal to, because if it's equal to 0, it's got two real and equal roots, and it's got two real and distinct. So what is our b? 9k, 3k squared minus 4 times 9 times k is greater than 0. That's 9k squared minus 36k is greater than 0. So to solve something like this, you look at the roots. It's just a quadratic inequality. And that gives me 9k squared minus 36k equals 0. 9k is a common factor to give k minus 4. So k is 0 from the first place, and k is 4. So that answers what the roots are, so I draw it. So we've got 0 and 4. It was a positive k squared. So it looks something like that, where that's 4 and that's 0. And it says we want to be greater than 0, so above the x-axis. Well, above the x-axis, I'm continuing that way, and I'm continuing that way. So our final answer is k must be less than 0, or k must be greater than 4 for the range of values. And we're done there. SQA Higher Maths 2025, Paper 2, Question 2. Express 2x squared plus 16x plus 5 in px plus q squared plus r form, completing the square. So how this works is, you take 2 as a common factor of the first terms, x squared plus 16x, so that becomes 8x. Then you've got plus 5 hanging out, and you complete the square into x squared plus 8x. So that's x plus 4 all squared. Remember to take away 4 squared. But that's stuck inside this bracket, and the 5 is hanging out on the outside. So that's 2x plus 4 squared. And I'll have to do 2 16ths, which is 32, plus 5. So finally I get 2x plus 4 all squared, minus 32 plus 5 is minus 27. And we're done there. This has been Core Maths today. We have done a Polynomials and Quadratics Masterclass for Higher Maths. Hopefully you found that useful. Remember, you get your cheat sheet and your checklist in the description, and also you can get the Clelland Maths Pro Vault PDF to try some of these questions yourself. And if you're stuck, join the members only channel because you'll get access to the full video for that. Plus, you will also get access to the last minute live stream the night before the exam. It's a big one. Take care, stay safe, and I'll see you soon.